Using a for every statement, what is the frequency of light that has a wavelength of 6 times 10 to the negative 8th meter? So as you read, the speed of light is 3 times 10 to the 8th meters per second, or meters for every hertz. And that's the for every statement that we're going to go ahead and use right now. For every 3.0 times 10 to the 8th meter, there is 1 hertz. That is a given, and we know from our problem that we're trying to find a frequency, so the amount of hertz for every 6.00 times 10 to the negative 8th meter wavelength. So our second for every statement, for every 6.00 times 10 to the negative 8th meter, there is blank. That's what we're trying to find. All right, as you recall, the relationship between wavelength and frequency is indirect. So that means is that as your wavelength increases, the frequency will decrease, and vice versa. In our case, the wavelength went down. It decreased from 3.0 times 10 to the 8th to 6.0 times 10 to the negative 8th. So we're trying to find by what factor that decreased. I'll just change the color really quickly. So to go from 3.0 times 10 to the 8th to the 6.0 times 10 to the negative 8th, we need to divide. And in order to figure out what number to divide by, you're going to take the bigger number and divide it by the smaller number. So the bigger number here is the one that starts with a 3. So 3 divided by 6 is a 0.5. And then we can figure out what the factor is to go from 10 to the 8th to 10 to the negative 8th, and that is 10 to the 16th. Again, you want to try to do that without using a calculator. You want to try to practice that scientific notation. All right, so remember, if the indirect relationship means that if you are dividing it here, you are going to have to multiply it on the other side. So I'm going to multiply it on the other side by the same exact factor. So times 0.5 times 10 to the 16th. So times 1, it's going to give me the same exact number. I'm just going to go ahead and move the decimal to put it into a proper scientific notation. So that's going to give me 5.0 times 10 to the 15th hertz. And that's the frequency that's equivalent to this wavelength of light.